This is the Similar Figures Target number 25 quiz review. So hopefully you finished this in class. If you didn't, you finished it for homework. The first question, we're trying to find the scale factor between these two figures. Now remember, the scale factor is some number that we can multiply each number in the smaller figure by to get the matching number in the bigger figure. So my first thing to do is find matching sides, or corresponding in math terminology, corresponding sides. So this short side here, I can see it's between these labeled angles. It matches up with this shorter side here, because on this figure, it's the side between these two strangely marked angles. So 2 times what gives me 12? The answer is 2 times 6. So the scale factor is 6. That means I can multiply any measure on the small figure by the scale factor to get the matching or corresponding measure on the large figure. So 2 times 6 gives me 12. 4 times 6 would give me 24 here, but I don't care about that one. I care about x here. So x matches up with 8. So 8 times 6 gives me 48. So this side is 48. Next up, I'm dealing with scale factor and a missing length again. This one's a little bit trickier because the smaller figure is in a different position, so it might be difficult to tell which side matches up with the other sides. The way I do it is I look at the first smaller figure. It's got a small side, a medium side, and a long side. So my small side here has to match up with the smallest side on this figure. Small side, medium side, largest side. So the small matches up with the small side. The medium side matches up with the medium side, and the long side matches up with the long side. So one way to solve this is using scale factor. Since I asked you for scale factor, I'm trying to find out 10 times what gives me 12. And you might look at that like, I don't know, I can't do that mentally. Well, you can work backwards. You can take 12 divided by 10, I should say divided by 10, will give me 1.2. My scale factor here would be 1.2. I just worked backwards. So 10 times 1.2 gives me 12. If I know my scale factor, now I can take 20 and multiply by 1.2 by that scale factor and get my matching side here of 24. So another way to solve this, just to bring some other concepts together, I could take the ratio of the small side to the large side on each triangle. So I could take the small side compared to the large side on the small triangle, and the small side compared to the large side on the larger triangle. Mentally, I can see here that 20 is 2 times 10. So x must be 2 times 12. X would be 24. Moving on. These scale problems should be a slam dunk. Just make sure you put in labels. The scale on the map is 1 centimeter to 50 kilometers. It says 2 cities are 280 kilometers apart, which means, since I'm using labels, I know where to put that number in my other ratio. I'm doing centimeters to kilometers, so my other ratio has to be centimeters to kilometers. To solve this, I take 280 times 1 and then divided by 50, and I get 5.6 centimeters. The next problem is same as the last problem, just different numbers. I've got a scale of 2 inches to 500 miles. Two cities are 8.5 inches apart. So I know to put my 8.5 here. If I'm doing a ratio with inches to miles, this other ratio has to be inches to miles. So I can find out how many miles they are apart in real life. So I take 8.5 times 500 and then divide by 2, and I'll get 2,125 miles. Next up, the first tricky triangle. So here I've got one triangle inside of a larger triangle. So for the small triangle, it has a side of 6 and a base of 8. For the larger triangle that I'm going to try to draw here with my mouse, we know the base is x, the measurement we're trying to find, but the side between A and B here, the side is not 9 and it's not 6, it's 9 plus 6. The side from A to B is 9 plus 6, or 15. So now, a couple different ways to solve this. I could try to find a scale factor. I know the sides, so 6 times what gives me 15? The answer is 2.5. So then 8 times 2.5, x must be 20. Or I could solve with a proportion. I'll take the ratio of side to base for each triangle. Side to base. So I'll take side over base. The side on the small triangle is 6. The base is 8. The side on my larger triangle is 15. So the base is x. 15 times 8 divided by 6 will give me 20. Either way, I'm going to get 20. So I could solve with scale factor, I could solve with a proportion. Here we've got the shadow problem, the other tricky triangle problem. We've got a tree with a height of 10.5 feet and a shadow of 11.25. Another tree, we don't know the height yet, but we know the shadow. What I'll do, I think I'll use a proportion here. I could use scale factor also, if you like using scale factor. If I wanted to use scale factor, I take 17.5 and divide by 11.25, and I know what number to multiply by. But for this one, I like proportions. I'll take a ratio of the height to the shadow of the large figure here, and height to shadow of the small figure. If you chose to do the ratio of shadow to height, that's fine, as long as you do a ratio of shadow to height on the other side of your equal sign. So now I'm solving this. I'm taking 17.5, multiplying by 10.5, and then dividing by 11.25. And my solution is h equals 16.5 3 repeating, so 16 and a third feet, including labels here. Okay, another height and shadow problem. We've got a 6-foot man, we've got a 9-foot shadow, and we've got a kid. We don't know his height, but we know he casts a shadow of 6 feet. So we can solve these with a proportion again. I like to do height compared to shadow, so I do 6 over 9, the height compared to the shadow for the man, and then the height compared to the shadow for the kid. So we could take 6 times 6 divided by 9, and the height is 4 feet. Notice the labels. Okay, the rectangular room. So this room is a rectangle. It's a scale drawing, so that means if it's 10 inches by 8 inches, it means it represents a room in real life. So I've got to find out how many feet each wall is in real life. Well, the scale is 1 inch makes 2 feet. 1 inch on the drawing is 2 feet in real life. So that means if I've got 10 inches in real life, I've got 20 feet. And if I've got 8 inches on the drawing, 8 times 2, that means I've got 16 feet in real life. So my first step was convert inches on the drawing into feet in real life. Now I need to find the area. So the area, how much space this covers, is 20 by 16. So that gives me 320 square feet. That's feet square, square feet. That means it takes 320 square feet of carpet to cover this room. So step 1, convert inches to feet in real life. Step 2, find the area. Step 3, find the cost. So if it's 320 square feet and every one of those square feet costs $4.50, I can just multiply and I'll get $1,440. So just to recap, I used the scale drawing to find out how big the room was in real life first. Then I found the area. Then I found the cost. If you took 10 inches by 8 inches and multiplied those together, you'd get 80 inches squared. And then you tried to convert that to feet, you'd only have 160 feet squared. Square feet, I mean. That wouldn't work. Get a much different answer. Last problem. Statue of Liberty. We're given the ratio, or we're actually given the real life statue's dimensions. 46 meters, and the pedestal is 47 meters. And on the model, we're told the pedestal is 9 centimeters. So we've got to find the height of the statue in the model. Now you might be able to notice 46 and 47 are really close. So using your powers of estimation, this S must be really close to 9. So I could take the ratio of the statue to the pedestal, and the statue to the pedestal. Solve this. When I solve, I find that the statue is 8.8 centimeters. And since they asked me, or I asked you actually, the height of the entire model, 9 plus 8.8 gives you a total of 17.8 centimeters. Since we're rounding to the nearest centimeter, 18 centimeters is our answer.